let's now walk through a LeChatelier's principle free response example as you might see it on an AP exam. So a rigid container holds a mixture of graphite pellets, which is the solid carbon in the reaction, water gas, carbon monoxide gas, and hydrogen gas at equilibrium. State whether the number of moles of CO in the container will increase, decrease, or remain the same after each of the following disturbances is applied to the original mixture. For each case, assume that all other variables remain constant except for the given disturbance. Explain each answer with a short statement. So I'm going to walk through each of these, and for A through D, I'll use a different colored ink. And I'll talk through what would be the written short statement, and then I'll show you the short statements at the end. So again, I want to just highlight for a second. We are looking at the effect of this. Oops, that's not a highlighter. We're looking for the effect on CO. So we're looking for how does this change, okay? So we got to just keep that in mind. So first of all, letter A, additional H2 gas is added to the equilibrium mixture at constant volume. So if I increase my H2, I've created a disturbance on the right-hand side of the reaction where I now have too much H2 and I need to use it up. How do I do that? I shift the reaction to the left. And by shifting the reaction to the left, I'll see my concentrations of my products decrease and my reactants increase. So I would expect to see CO decrease. Okay? Now, what about part B? Part B says the temperature of the equilibrium is increased at constant volume. So it's an endothermic reaction, which means that heat can be considered a reactant, right? We're absorbing that heat. So if we increase the temperature by adding more heat, so if I increase the temperature, I've created a disturbance on the left side of my reaction that's going to drive it to the right to use up that excess heat, okay? So in this case, the reaction is going to go this way, to the right. And that will see my CO concentration increase, okay? All right, now letter C says that the pressure, it says that the volume is decreased, but a decrease in volume means an increase in pressure, okay? And an increase in pressure favors the side of the reaction with fewer molecules of gas. So an increase in pressure will favor the left side because it has fewer molecules of gas, which means we would see the CO concentration decrease. Okay. And then finally, the graphite pellets are pulverized. So pulverizing the graphite pellets just increases the surface area. It increases the rate of the reaction, right? Increases the rate of the reaction, but it doesn't do anything to the equilibrium because notice it's a solid, and so that solid isn't included in our equilibrium expression at all. So we wouldn't expect to see a shift in the equilibrium. We would just expect to see the reaction happen faster. So in this case, we would say that the CO would remain the same, where there would be no change in the concentration of CO. All right, so let me just show you the answers with the written short statement that you would be expected to provide, which I talked through, but here it is for your reference should you want to write down the statement. But in part A, we would expect the concentration to decrease. In B, we would expect it to increase. In C, we would expect it to decrease. And in D, it would be unaffected.